Okay, so today what we are going to do is actually try to find out what is the internal force at different cut. So before we do anything, what we need to do is we need to remember for the axial load, normal force, it's normally going to be perpendicular to your cutting plane. And your shear force must parallel to your cutting plane. As for the moment, the torque is going to be perpendicular to your cutting plane. However, your bending moment needs to be parallel to the cutting plane. This will help you to identify what's this load, and later on you can make a decision which equation you are going to use to calculate the stress due to different load. So now let's take a look. What we need to do is try to figure out what is the internal force in the bar BC. So which means we are going to do a cut somewhere here. So this is going to be our cutting plane. We are going to assume that the cutting plane will be Z distance from C location. So now what you need to do is try to pick a side as your FBD. So are you going to pick the upper side or the lower side as your FBD? I would recommend you to use the upper side as your FBD, because if you use the lower side, you had a fixed end. If the reaction force at fixed end was wrong, then everything will be wrong, right? Especially this is a 3D problem, so which means the reaction force at A fixed end will be much more complicated. Okay, so now we are trying to draw the FBD, and then we had 3 forces. So the first thing we need to do is actually set up the coordinate system. So this is a coordinate system, and then we need to find out what is the reaction force at your cutting plane. So the first thing we are going to do is try to find the force, and then we find out the moment, because the force is much more easier. So take a look at here. We need to have 200 Newton go up to balance the going down force, right? So now what you need to do is try to find it. Is this force going to be called normal force or shear force? So take a look at here. You can see this force is actually perpendicular to your cutting plane. So which means this is actually going to be a normal force. And then let's move to the different forces. So we can see we are going to have the force in the x direction. So now is this force going to be the normal force or the shear force? You can see the arrow is actually parallel to the cutting plane, so which means this is a shear force. And this 500 Newton will also parallel to your cutting plane, so that's going to be a shear force. So now what we are going to do is actually figure out the moment. So we know this is the dimension we had so far, right? So now let's take a look. Is 200 Newton going to create any moment? The answer is no, because the force parallel to the dimension, there's no moment will be created. Okay, so now let's move to the second force. Let's do the 300 right now. So you are going to use your right hand and try to curl. So you can see 300 multiply the z distance. You are actually going to create a moment around y-axis. So which means we are going to have moment in the y direction, and it will equals to 300 force times the dimension z. So now let's take a look. Is this moment going to be called as torque or the bending moment? So you can see it's parallel to your cutting plane, so that's going to be bending moment. So we do the same thing for the 500. You can see 500 multiply the dimension z will also give the force, the moment in the x direction. And we can see this moment is also parallel to your cutting plane, so that's why it will be bending moment again instead of the torque. So do we have any forces or the moment? So if you use one force goes through every dimension, you find out, you figure out everything, then that's all we had. So you're probably going to ask me, how could I tell like 300 Newton multiply the z distance will create a moment around the y-axis? So first of all, you can use your right hand, and right hand rule, your thumb will be in the y direction. So this can tell you are going to create moment around the y-axis. Secondly, we can use the cross product to help us to find out the moment direction also. So 300 Newton is in the x-axis. So moment is equals to the force cross the dimension. So which means we need to cross the dimension. So we can see the dimension is in the z direction. So which means x direction cross the z direction, we actually going to have y. And in this way, you can also tell that the moment is in the y direction. So we had two ways. You can either curl your hand, or you can try to use the math to help you identify the direction of the moment. So let's take a look at this problem. This is the same problem. However, what we are going to figure out is actually try to figure out if we were trying to cut at y distance to the B like this, what is the internal force at the new cut? Are we going to have the same cut? No. Are we going to have the same internal force? The answer is no. So let's take a look. Again, we are going to use the free end side as our FBD. So this is your cutting plane, the free end side FBD. So the first thing you are going to do, again, try to set up the coordinate system at the cutting plane. So now the next thing is try to draw the external force. So now let's take a look. This time, if we need to balance the 200, we still go to the z direction, positive z direction. However, is this 200 Newton still going to be the normal force? The answer is no, because you can see right now the force is actually parallel to your cutting plane. So this is actually the shear force. And we do the same thing for the 300. And is this force parallel or perpendicular to your cutting plane? Parallel. So which means it's a shear force. And then let's see the force 500 in the y direction. So now you can see this force will be perpendicular to your cutting plane. So that's why the role have changed. It actually becomes to the axial load, the normal force. It's not the shear force anymore. So which means every time when we had a different cut, you have to base down your cut and your FBD to identify is this force going to be the normal force, shear force, or and so on. Okay, so now we done all the calculation for the force. So which means we will be able to move to the moment calculation. So now I would recommend you to use one force go through every dimension so that you are not going to missing any load, missing any moment. So we are going to start with the 200 Newton right now. So we can see 200 Newton multiplied 2 meters is actually both are parallel to each other, which means they are not going to create any moment. So which means we are going to still use the 200 Newton, but we are going to use the y distance. When you curl your hand, you can see it's actually going to create moment in the x direction. So that's why created by the 200 Newton multiplied y. And is this moment going to be the bending moment or the torque? We can see it's actually parallel to your cutting plane. So which means it will be the bending moment. Okay, so we finish one force, then we can move to the next force. So let's go to 500 right now. So we can see 500 cross the 2 meter here. We do create moment in the x direction, negative x direction again. So which means we are going to get the moment created by the 500 times the 2 meter. Use one force, go through each member so that you're not going to missing any moment. You can see the moment in the x direction is actually created by two forces. One is going to be the 200, another one will be 500. So do not forget. So nextly, we're still going to use 500, and then we are going to try to times the y distance. However, these two things, force and dimension, is actually parallel to each other, so which means it's not going to create any moment. So which means we can move to the next force, 300. And then first of all, we are going to use the 300 times the 2 meter. And if we curl our hand, we can see that is going to be the moment around the positive y direction. So now back to the question again. Is this moment going to be the bending moment or the torque? So we can see this moment is actually perpendicular to your cutting plane. So which means it's actually going to be the torque. Are we done? No, we still had one more dimension we haven't used yet, which is the 300 times the y. So if we try to use the force, curl your hand, you can see 300 across the y dimension, we are going to create the moment around the z-axis. Or what we can tell is 300 is x direction and across the y dimension, which means we are going to have z to get our moment, z direction our moment. We can see the internal force in the z direction will go this way. Now how we are going to calculate 300 times the y dimension. And again, is this moment the torque or the bending moment? Yes, it's parallel, so which means it's a bending moment. So now let's go back to talk about why we need to figure out each force. Is it going to be normal or shear or the bending moment or the torque? Because we had a different formula to calculate the stress. So for the normal force, we are going to create normal stress. And this is, we use this equation to do the calculation. However, if it is a shear force, we are actually going to create shear stress. And we are going to use VQ over IT to calculate the shear stress. If it is the bending moment, then which means we are going to get the stress, flexural stress, which is the normal stress, which is going to be calculated as my over I. And then for the torque, it's actually going to create the shear stress, and we are going to use T rho over J to do the calculation. And this is why we need to identify the force first, and then we know what kind of the stress is going to be produced by this force, and we also know which formula we are going to use to calculate the stress.